Hello, this is Mr. Wynn. Today's video is 4-7, transformation of quadratic graphs, and we're going to add a focus on converting. So, graphing a quadratic equation is easiest if it's in vertex form. Y'all have seen that form before. A makes a graph taller or wider. Taller means vertically stretch, wider means vertically compress. The negative in front flips the graph upside down, meaning reflect across the x-axis. H is the horizontal shift, left and right, but just opposite. K is the vertical shift, up and down. It's normal, and H, K is the vertex. So we've seen this before. You can write it down on the side, start from the origin, either go left, right, up, down, have your starting point, and then draw the picture. So that's the transformation part when we have vertex form. But this video is more about converting. So here's the other one. There are two forms of quadratic equations you take, each good for different things. Vertex forms I just talked about on the left. Standard form is the thing on the right. Vertex form has no work needed for a lot of things. Finding the vertex is our starting point. It's always h, k. Remember, it's either left to right or up and down from the origin. That lets us sketch quickly. If you see the picture, you can do domain and range. You can answer min or max, depending if the picture's going up or down. You can find the value because you know the vertex, and then you also answer how many real roots. Standard form can find the y-intercept easily, and it can answer min or max. But you got to show work to find the vertex, which then you need axis symmetry. But once you have the vertex, then you can do domain and range, then you can do min or max value. But this has the benefit of solving for the real roots via quadratic formula. That's the main benefit standard form has. That and technically y-intercept as well. But everything else, vertex form is better for. So you got to be able to work on both forms. Alright, so changing from vertex form to standard form, there's 3 steps I wrote on the side. The first is to expand the problem, meaning get rid of the exponent. Y'all know that squared power means to write that thing in parentheses twice. So this is really y equals -2, parentheses x plus 4, another parentheses x plus 4, and plus 7 over here. So this is something times something times something plus something. This is triple multiplication. Make sure you do 2 at a time. I'm going to take care of this part first. I'm going to distribute that -2 into this. So we're at y equals -2x minus 8 times x plus 4 plus 7. So now I have a parentheses times parentheses plus 7. When you have parentheses times parentheses, you know to double distribute. So everything in the first parenthesis, everything in the second parenthesis. So that times that gives me -2x squared minus 8x. And this -8 times both of them. -8x minus 32, and then bring down that plus 7. Combine like terms, and then you're done. So the x's combined. So -8x minus 8x is -16x. And then the -32 plus 7 combined to make it a -25. Y equals. That is our answer. So 3 steps. Expand, meaning get rid of the exponent. So write the parentheses part twice, multiply it out, then combine. So that's short and simple. Be able to do the opposite. So I did the same problem, now we're going to go the other way. So converting from standard form to vertex form. Alright, the steps are a little different. So if you have standard form, again good for quadratic formula, but not so good for quickly sketching, you need to find the vertex and another point, which I said I recommend the y-intercept. So the vertex, to find vertex, you gotta do axis of symmetry. So AOS is -b over 2a. So positive 16 over 2 times -2. That's 16 over -4, which is -4. Once you have the axis of symmetry, remember that's the x part of your vertex. You gotta plug that in. So remember, plug in AOS. So what I mean is, wherever x is in the original problem, you put -4 there. Make sure you use parentheses. 16 times -4 minus 25. If you type that in the calculator, let's see, 16 -32, positive 32 minus that is 7. Alright, so that's the 7. That's my vertex. So I found the first one. I need another point. Well, hopefully y'all remember axis, standard form, the y-intercept is always c. So my y-intercept is 0, -25. So step 1's done. I had to just mark there. Step 2, plug those 2 things into the vertex form formula and solve for a. So here's what I mean. The vertex form formula was y equals, I'll do over here, vertex form a parentheses x minus h close bracket squared plus k. Well, our 2 points has those 4 letters. -4 is h, 7 is k, and our y-intercept, that's the x comma y. I remember the vertex is always h comma k. So I plug those numbers in. So is y equals, well, y was -25. Equals, we don't know a, we got to solve for that. X was 0 minus h. Remember, this is opposite. So really that's -1 times -4, or opposite of h. So that makes it a positive 4. So plus 4, close bracket squared, and plus k, k is 7. Now we just simplify. So I'm going to leave the left side alone. This is a, this inside the parentheses, 0 plus 4 is 4. I got to square that, plus 7. Alright, so -25 stays there. Alright, 4 squared is 16, so that's 16a plus 7. We're solving for a, so we got to subtract that 7, both sides. So that's -32 equals 16a. Last thing we got to do is divide by 16. So -2 equals a, or a equals -2. Final step, so step 2 done. Plug in the vertex and a into the vertex form formula. So looking back at this formula here, we're not going to change y. We're going to leave y alone. Y equals a we found was -2. Parentheses, leave x alone. But h, remember that's opposite, so that's plus 4, close parentheses squared, and plus k, k was 7. That's the answer. Notice that's the exact same from example 1. I did the same problem, just going backwards. See, it's -2, x plus 4 squared plus 7. -2, x plus 4 squared plus 7. Alright, so that's how you convert back and forth. We're going to do that a lot in this class. Alright, the last example, build a graph or sketch from either form. And to sketch, you only need 2 things. You need the vertex, meaning the starting point, and then a, which controls the direction of opening or tells you if it's flipped or not. Vertex form is the best. Remember the vertex is h comma k, or if you think about it the old way, we know that plus 4 means left 4. So that means left 4 of the origin, -4, and that plus 7 means up 7. Alright, so we've always known hk. Alright, and then a is negative. Now negative is -2, so a is negative means flipped. If you want to talk about the 2 meaning taller, you could do that as well. Negative, so that's flipped. I'm not going to worry too much about the taller part. So all you do is put your starting point, vertex, the -4, 7, and I'm not drawing the axes, and flip means the upside down u. That's all you need. Once you have the picture, you can do domain and range, max, min, all the other questions. Alright, this other side should be pretty much the same picture, but we have to do some work. So we need a starting point. To find the vertex, you got to find axis of symmetry. So AOS first. So -b over 2a. -b is positive 16 over 2 times -2. So 16 over -4 gives me -4. Alright, good. Just like this other side. So the vertex, we know the x part's -4. To find the y, you got to plug in the AOS. And AOS. So what I mean is -2 parentheses -4 close bracket squared minus 16 times -4 minus 25, and remember that will give us positive 7. So the same vertex as before on the left side, and then a again is negative. Negative means it's flipped upside down. Alright, with those 2 things, I can graph the picture. So put your starting point. Again, it's just in the middle of nowhere, but it's -4, 7, and just flip meaning upside down u. And those arrows are diagonal. We now do domain and range, min, max, all that good stuff. Alright, here's a practice problem. Convert the following to standard form. Basically expand it, double distribute, and combine terms. Get that answer. And you can do that. You should be good for class. Again, this is Mr. Wynn. Thanks for watching. See you in class. Bye.